Hi everyone, today our video is about runtime management in that virtual machines is also study. So first introduction, what do you mean by runtime system? It refers to the set of libraries on which the language implementation depends for correct operation. Some parts of runtime obtain all the information they need from subroutine arguments. Others require more extensive knowledge of the compiler or the generated program. So runtime system, the simple cases, the knowledge is a set of conventions that the compiler and runtime both respect. And more complex cases, the compiler generates program-specific metadata that the runtime must inspect to do its job. Many examples of compiler runtime integration have been discussed, that is garbage collection, variable numbers of arguments, exception handling, event handling, coroutine and thread implementation, remote procedure call, transactional memory, dynamic linking. The length and complexity of the list above generally means that the compiler and runtime system must be developed together. Some languages have very small runtime systems. Most user-level code required to execute a given source program is either generated directly by the compiler or contained in language-independent libraries. Other languages have extensive runtime systems. Example, C# is heavily dependent on a runtime system defined by the Common Language Infrastructure Standard, which depends on data generated by the compiler. Another is virtual machines. What do you mean by virtual machine? Virtual machine provides a complete programming environment. Its application programming interface provides all requirements for execution of programs that run above it. Term used for environments whose level of abstraction is comparable to that of a computer implemented in hardware. Virtual machines tend to be characterized as either system virtual machine and process virtual machine. What do you mean by system virtual machine? It faithfully emulates all the hardware facilities needed to run a standard operating system that includes both privileged and unprivileged instructions, memory mapped input-output, virtual memory, and interrupt facilities, sometimes referred to as virtual machine monitors. The second is process VM. It provides the environment needed by a single user level process, the unprivileged subset of the instruction set, and a library level interface to input, output, and other services. The next is Java Virtual Machine. It started as the development of the language Java in 1991 at Sun Microsystem. First public release of Java occurred in 1995. Code in the JVM was entirely interpreted. JIT compiler added in 1998 with the release of Java 2. Java Virtual Machine is an important topic. It is asked in previous K2 question papers. We will look JVM architecture summary. Interface provided by the JVM designed as a target for Java compiler. Provides direct support for all the built-in and reference types defined by the Java language. Enforces both definite assignment and type safety. Includes built-in support for many of Java's language features and standard library packages, including exceptions, threads, garbage collection, reflection, dynamic loading, and security. Usually Java bytecode JBC is produced from Java source. However, compilers targeting the JVM exist for many languages including Ruby, JavaScript, Python, Scheme, C, Ada, COBOL, and others. JVM storage management storage allocation mechanism in the JVM mirror those of the Java language. It consists of global constant pool, set of registers, stack for each thread, method area to hold executable bytecode, heap for dynamically allocated objects. A trivial hello world program is shown here. Here class hello public static void main string args system.out.println hello world. It is the content of the JVM constant pool of the program as in the example. The ASCII contain null terminated character string names. Most other entire pairs an indication of the reference to one of or more additional entities. This output was produced by Sun Java tool. This is Jvm class files. Class file is stored as a stream of bytes. Typically, real file provided by the operating system could just as easily be a record in a database. Multiple class files may be combined into Java archi file or .jar file. This is JVM bytecode, that is JBC. Stack-oriented operands and results of arithmetic and logic instructions are kept in the operand stack of the current method frame rather than in registers. Instruction set, the version contains two categories: load store, arithmetic type conversion, object management, operand stack management, control transfer, method calls, exceptions and monitors. JVM bytecode for a list insert is shown this program. Java source and bytecode for a list insertion method of the above program is shown. Java source and bytecode for the list insertion method. The output on the right was produced by Oracle's Java C compiler and Java P tools with additional comments inserted by hand. This is Common Language Infrastructure, that is CLI. Began at Microsoft operation in the late 1990s. Need for interoperability among programming languages running on Windows platforms. For the .NET specification for CLI virtual machine was standardized by ECMA in 2001. Architecture and comparison to the JVM. There are similarities between CLI and JVM. Both systems define a multi-threaded stack-based virtual machine with built-in support for garbage collections, exceptions, virtual method dispatch, and mix-in inheritance. Both represent programs using a platform-independent, self-descriptive bytecode notation. For languages like C#, the CLI provides all the safety of the JVM, including definite assignment, strong typing, and protection against overflow or underflow of the operand stack. Architecture and comparison to the JVM. Contrast between CLI and JVM. Richer type system for CLI, richer calling mechanisms in CLI, unsafe code made explicit in CLI, miscellaneous CLI support. The common type system consists of built-in types, that is integers, integer 8, 16, 32 and 64-bit lengths, both signed and unsigned. The native integers are there. It is supported by hardware, again both signed and unsigned. Then IEEE floating point is there, both single and double precision, object references and managed pointers. The common type system constructed types, dynamically allocated instance of class, interface, array, delegate types. The methods are of function types, properties, getters and setters are objects, events, list of delegates associated with an object, value types, records, unions and enumerations, boxed value types, values embedded in dynamically allocated objects, function pointers, references to static functions. There are typed references, that is pointers bundled with a type descriptor. Unmanaged pointer, as in C, can be point to just about anything and support pointer arithmetic. Then another is common language specification. It defines subset of CTS that most languages can accommodate, omits several of the types provided by the CTS, imposes restrictions on the use of other types, establishes naming conventions, limits the use of overloading, and defines the operators and conversions that programs can assume are supported on built-in types. None of these restrictions applies to a program components that operate only within a given language. Metadata and assemblies. Portable executable assemblies are the rough equivalent of Java or .jar files. Contains the code for a collection of CLI classes based on the common object file format originally developed for AT&T System Unix. The Common Intermediate Language, that is CAL, version 4 of ECMA standard defines approximately 250 instructions. CL bears a strong resemblance to JBC. Any differences stem from the assumption that CL will always JIT compiled. In next video, I will talk about late binding of machine code. Till then, bye.